It's time for Pure Performance.
Get your stopwatches ready. It's time for Pure Performance with Andy Grabner and Brian Wilson. Hello, everybody, and welcome to another episode of Pure Performance. My name is Brian Wilson, and as always, I have with me my co-host Andy Grabner for a subdued episode of Pure Performance. Hello, Andy.
Hello, Brian. You have a very interesting, subtle voice today.
Well, we're both kind of feeling a little slow today, so I figured we can have more of a public radio sort of version of our podcast today.
Yeah, why are you slow today? What's wrong?
Oh, it's just been a long day already, and stuff with my child, and just a lot of work coming in, and feeling overwhelmed, Andy, overwhelmed by life. But that is the way how it goes, or so it goes, as Kurt Vonnegut used to say. How about you? You seem very, when I contacted you today, you seemed a little subdued.
Well, it might be related with, if I look out the window, and it is April 6th today, and it's totally foggy in Boston, and it's very strange. It just feels like November, and it feels like I have to go to sleep. Maybe that's part of the reason. But no, other than that, I think I'm excited about what we're going to do today, because I think this time we do not have a guest of honor.
Right.
Well, you're my guest and I'm your guest, kind of.
Correct.
I would say in this case. And we thought, what are we going to talk about today?
We're gonna, way back when we first started this podcast, just about a year ago, if you believe it or not, it was May of last year, and I believe this one is airing in May. So we're about somewhere at our 1 year anniversary. We had talked about some common problem patterns, right? We did an episode on common Java problem patterns and common .NET problem patterns, and it's always there's a lot of them. Not a million of them, right? But there's a finite set of very common problem patterns, as you've seen over and over again, and we've all seen over and over again. But in those early podcasts, we could only cover so many of them. So we figured, you know what? It's about time to get back to some of the common problem patterns. And I think, we have some interesting ones today, because with the changing architecture that's been going on, we're seeing some of what we might call new problem patterns. But, might even call them the new old problem patterns. Yeah. So we're going to touch on a couple of those today and continue from there.
Yeah, cool. What do you want to get started with?
Well, let's see. It's not like we didn't discuss this before, so we'll pretend. I don't know. Let's, the one thing I've been hearing quite a lot about is multi-threading. And, we have, we're not going to get too deep into it, but a lot of people are probably familiar with, I believe it's Akka, right? There's a lot of very highly asynchronous, multi-threaded applications out there that are very efficient and very awesome, and very confusing when you try to look at what they're doing. But multi-threading in itself is not bad, correct, Andy?
No, not at all. And I think we also need to differentiate a little bit about multi-threading. And I think other approaches where you talk about event-driven, where you then have multiple threads taking off the work, right, basically really constantly working, and nobody's waiting on them per se. But then there's going to be callbacks where you just call the next chain of event. So I think this is also one thing to understand. There's a difference in just spawning threads and doing something asynchronously versus some of the frameworks that have really been optimized for really squeezing the best out of multiple threads that you have available, and just coming up with new development models and making hopefully code more efficient and execution more efficient, right?
Right, and I think it goes without saying too that even with if we're not talking about the event-driven, highly optimized versions, when you're talking, if we're just saying transaction comes in and spawns multiple threads for some asynchronous activity, that's not necessarily even bad on its own as well. But there are dangers and pitfalls that can arise, and I guess from what you've been seeing a lot in your PurePath program, which, by the way, shameless plug here, Andy. runs our free trial program, so that when you do download our Atmon program, you can share your PurePaths with him, and he'll take a look at them, which is where he sees all these problems over and over again. You're seeing some patterns when it comes to multi-threading, what these problems are that we come across. So let us discuss what that is then.
Yeah. So first of all, I'm not actively looking for these. I'm not going in and say, does this have is it a multi-threading issue? I typically start with, do we have a performance problem? Do we have a resource issue? And typically you see this by, load on the system is going up. So I'm looking at incoming number of transactions, and then I'm looking at response time. And typically what we see is that at some point in time, response time simply goes through the roof. And at the same time, we see, however, that these transactions are actually not doing a whole lot. They're mainly spending time either in waiting on something else, or they are actually not doing anything other than, not actively waiting on an object that is then woken up by a framework, but actually waiting on the availability of a background thread that they are requiring. So what I've seen more and more so, especially with frameworks that make kind of these, asynchronous programming easier, where you can create a work item and put it on a thread in a queue, and then some background thread picks it up, which is great for developers. But what I've been seeing is that sometimes people are misusing that. So one blog post that I just have in front of me, and you can, if you want to read it, it's on on the Dynatrace blog.
And we'll link to it. Yes.
Yeah, it's the detecting the N+1 asynchronous thread problem pattern.
Did you just say N+1?
I know I said N+1.
It's always N+1, right? No matter where we go. But that's not the heart of it, right? Continue. I just wanted to acknowledge that we did say N+1 yet once again, but please, people.
Yeah. So, but in this case, and thanks to our colleagues in Gdansk, they shared this PurePath with me because they've been using our product to actually analyze the work that they are doing, and then they sent me a PurePath, and they had a problem that they wanted to solve, which was some of the reports were just running too slow, and the reports were querying a lot of data from the database, and then doing some calculation. And so the developers thought, well, if we have to go off a lot to the database multiple times to query data, why not just parallelize the whole thing? And so the loop that we have right now, where we crunch through the elements, we just spawn multiple threads for every element that we are iterating through in the loop, and then multiple threads will take care of it much faster, and then at the end we just wait for the result and everything will be fine and faster. So classical, I have a problem, divide it into smaller pieces, put it into background threads. Now, this worked well in a development environment, right? Because if you're the only one on the system, that's not an issue. But what this really meant is that for every incoming thread that was working on that report request, you had 2, 5, 10, 50 threads being spawned additionally, depending on how many data items they had to crunch through. And that's the classical N+1 query problem again. You have one main thread, and then for every data item that this main thread tries to process asynchronously, you have another thread, another worker thread, asynchronous worker thread. And obviously there's two problems with this. First of all, it is a load-related problem. That means the more load you have on the system, at some point you run out of threads if every incoming thread consumes more than one,
Right.
So that means you cannot scale. But even worse, or actually in combination with this is also a data-driven problem. Because what if you not have to crunch through 10 items, but 1,000 items, and then do you automatically spawn 1,000 threads? And do you have 1,000 threads available? And
I can imagine if you have to spawn 1,000 threads, you would also need the memory for those 1,000 threads as well.
Yeah, or you run into an exception where the JVM probably tells you, well, I cannot give you these threads, or at some point, maybe even the operating system tells you it's not possible anymore.
Right. So
definitely you run into resource issues. Now, the intent, understandable, why you want to parallelize some of this heavy lifting activity, but done in this way is not good. And what I then the way I see these problems now, when I analyze the data, I look at these long-running PurePaths, and it's also explained in the blog. What I like about the PurePath is not only the end-to-end traceability, but we also show you which thread is actually executing a certain method. So I can see the thread switches when it switches from one thread to another. And then there's another column which we call the elapsed time. It's like a timestamp. Yeah. It basically tells me when was this method executed, the next, and it's always relative to the entry point of the transaction. So the entry point is 0, right? Timestamp 0. Mm-hmm. And there you can easily always see, hey, it's interesting. We are trying to make a call from the main thread and then passing some work to the background thread. And there I have a gap from 1 second, 5 seconds, 10 seconds. So that means the system or the main thread is just waiting for the work to be picked up by the next thread. And the question is, why is that? And typically the answer is, well, there's just simply none of these background threads currently available because they are busy, because they're used by other main threads that are trying to do a similar thing.
Right. What strikes me about this one is this ties very directly to another common problem pattern we spoke of in that first or second episode ago, another threading issue, right? I think threading issues all probably come from a very similar problem, but makes sense, right? That when we were looking at time spent on the web server before getting to the JVM or the app pool or whatever, where you could say, all right, we're trying to make a synchronous call back to the JVM, and there's a long wait time before it gets to that. And again, you could see that from that elapsed time on the thread. But again, it's just not enough threads.
Yeah. And so what I typically now do, I think as a lesson learned, analyzing these problems. So I always look at, first of all, number of incoming requests on the front, right? How many requests are coming on the Tomcat? Then how many threads are active? And I'll try to actually calculate a ratio. So how many threads are active per certain transaction type? Because then you can immediately see, wow, this transaction, they only need one thread, so everything is synchronous, no problem. Oh, this transaction is consuming 3 threads. This one, 50 threads. So I kind of look at this and then better understand the real performance and resource characteristic of an implementation. Right. So this is a good one thing that I learned. Also, another thing that I learned, if you have a transaction that is heavily using multiple threads, then what tools like Dynatrace provide is it gives you the total execution time of all the threads. Because even though, let's assume you have endless threads available and everything is fast and you never run into a threading issue, but eventually your transaction is consuming resources, CPU cycles on the different threads. So what I always, in order not to be fooled by, this transaction is so fast, it only takes 100 milliseconds. But if I know that it takes 100 milliseconds on the main thread and it also consumes 100 milliseconds on 50 other threads, that multiplies up to 5 seconds plus 100 milliseconds. So that's always why when you try to optimize multi-threaded applications, then you always need to look at the total execution time of all the threads that are involved. And then especially track this over time, because you want to know when a code change actually changes the dynamic behavior. And even though the performance to the end perceived by the end user is still good or maybe even better, it may be that you just, and then you're now involving so many more background threads and you're in the end consuming a lot of more resources.
Right. And to give a kind of a pro tip to anybody who uses Dynatrace who might be listening, when you're looking at PurePaths, or I put the accent on the wrong PurePaths. That's the Christopher Walken way of saying it. When you're looking at PurePaths, you have 3 different times you can look at, right? And they all reveal different things about these patterns that you're talking about. Your response time is your basic time on the transaction, right? Your response time, let's say it's 50 milliseconds. That's how long it took from the entry point for the entry point method to complete, right? If it spawns off any asynchronous threads, though, that is not covered by that, right? Your execution sum for a PurePath is more along the lines of what you're talking about, right? Where it's a total of the entry point plus the sum of all of the different threads, even if they're running in parallel, right? So it's not, it doesn't reflect the true time that anybody or any of the systems are being parallelly impacted by, but it's the amount of time that transaction consumes. And then the third one we have is duration, right? And duration is going to cover the entry point of that method plus your async times for, but it's not going to cover parallel threads, right? So if you have two asynchronous threads fire off at the same time, the duration is going to include the length of the longest one.
Exactly. The duration basically is from when the transaction initially hits your JVM, for instance, until the last asynchronous thread is really done. And this is very actually great that you bring it up, because this is always sometimes misleading if people only look at response time.
Right.
And say, well, look at this code is super fast. It responds in 50 milliseconds. But then duration all of a sudden says, well, a second, 2 seconds, 5 seconds.
10 minutes.
And then 10 minutes, yeah. And basically what that means, the initial request comes in, is super fast, responds back to the end user. But what this request actually does, it spawns off something asynchronously that then goes off and does something. But to the end user, the transaction might be completed in 50 milliseconds. Right. But on the system itself, certain things are happening. So that's why, very good, Brian.
So just a little pro tip. Yeah, just a little pro tip to any users out there to put a pepper that in case you haven't looked at that.
Yeah, so response time, this is the time perceived by whoever initiated the transaction. Duration is how long does it really take from end to end, including all the asynchronous activity. Right. And then execution time, or total execution time, includes all the time of all the threads combined. So we can actually see the real resource footprint of that particular transaction. Yeah.
Yeah, and in terms of the threading, right? As we mentioned, threading is multi-threading is not necessarily bad, right? But being too heavy or having these delays is where it does get bad. And another thing, so you had mentioned some of the things that you do to look for it manually, right? You're looking at the number of requests, how many threads it's spawning, the amount of time it's being spent there. But again, and it's funny that it's me doing the plugs this time, but we just want to mention that with a lot of these common problem patterns, if you are using Dynatrace, we will identify currently in 6.5, right? We're identifying heavily asynchronous transactions, right? And then you were mentioning, I believe there's something else coming in the next release.
Yeah, in 7. So what we do on a PurePath to PurePath basis, just what I did manually all the time, basically looking at how many threads are involved. So we tag a PurePath and say this PurePath is synchronous, or this PurePath is asynchronous. And if it's asynchronous, we actually say thread heavy or thread medium. And then this was there since 6.5 and makes it easy to say, show me these PurePaths that are very heavy on threading. But what we now have with 7, we give you this view over a time frame, or over a timeline. So you can say, hey, under a certain load condition, or if I look at my load pattern over the course of the day, then I can see when load goes up, I all of a sudden see the number of PurePaths that have asynchronous issues also go up. Or if you have constant load and you are deploying a new version of your app into that environment, if you do some type of continuous performance engineering, continuous performance testing, and you look at Dynatrace and you can see, right now 5% of my threads are heavy on heavy on threading, and after the deployment it's not 5%, it's 50%. So immediately know you introduced probably a regression, and that makes it just so much easier, especially for architects or when you do code reviews, to say, before we probably don't want to let this into production, because first you want to sit down and figure out, was this intentional or not.
Right. All right. Any final words on threading?
No, I think what I just like also to build, what I always look at is just some charts where I think I mentioned it earlier, but I typically look at incoming transactions overall. Then I look at a number of threads involved. and always look at this ratio.
So
and
that'd
if
be the
you have
total number of threads, right? So
exactly.
Okay.
The total number of active threads, the total number of transactions that come in. And obviously, if you have a chance and if you have a tool that can do that, then split the transactions up into something that makes more sense for you from a business, from a feature perspective, right? Because typically in an application, you have certain requests that you see a lot, but typically very fast ones. I don't know, static resource requests or some heartbeats, and they are typically then diluting your averages. So if you have a chance and say, show me the number of requests that come in on that particular transactions and how many threads are involved, that will be perfect. And then trace this over time.
And you know what you could also do with that information? You can also track how much CPU time it's using, or how many memory resources it's using, and then find out, well, how much is this costing us in our cloud infrastructure that we're spinning up?
Exactly, right. And if you want to give another Dynatrace tip, so we would use business transactions for that, right? You create a business transaction for a particular feature, and then as a result measure, you can say, total CPU time, total execution time, total number of threads, total number of web requests, and all that stuff. This is.
Yeah, because again, as Andy brings up quite often, one of the things to be looking out for, the newest thing to look out for is what is the cost of a feature, right? And are you getting, and especially as we were talking to Karenka the other day, maybe you put it out, you find out people like it, and then you go ahead and optimize it, right? And these are all ways you can do that. Yep. So all right, so that's the multi-threading. Right. And we'll go into our next problem pattern now. And this one is everyone's favorite topic, the big buzzword, microservices, right? Microservices, and I guess maybe the problem pattern or whatever could be considered nano services. But there are, there's a whole bunch that we can talk about in microservices, but we're limited on time. So we're gonna just start covering a couple pieces, right? One thing to point out is a lot of the same problem patterns that we have without microservices get repeated with microservices, right? But with that introduction, Andy, what is the microservice du jour that you wanted to bring up today?
Yeah, well, I think it again, it comes back to, and I think you mentioned it in your intro, it took a word from the blog post. When microservices become nano, that's actually the title of a blog post that one of our users wrote, Stephen Ledoux. He showed us, and you can go on the blog, and maybe we post the link, I guess. Yeah. Yep. But basically, he was explaining that they were basically ripping apart the monolith into microservices, which is obviously great, but they were going too granular. And what the too granular actually meant is that they had one call again coming in the front, and everything that used to be done in the monolith, maybe in the same thread and the same process, obviously. Now, instead of processing all of this in the monolith in one container, they were having many calls going to these new services that were so fine-grained that they simply had a cascading effect almost, where you have, instead of one front-end microservice calls a back-end microservice, the front-end calls 20 times the back-end microservice, and that microservice calls another 20 times the next microservice, because they were just not thinking about correctly on how to structure the services in how granular they should be, or how which functionality should actually be combined in one service and where you need another one. And I think this is also where it's so critical before you sit down and do your microservice architecture, that you actually do some dependency analysis. So if you really rip your monolith apart across maybe class lines or functions even, then first think about what are the dependencies, how often do these classes call each other, how often do these functions call each other, and are you aware of the fact that when you then make a call, that you have a round trip over network,
right.
that you have to marshal and unmarshal a call, right? Depending on which protocols you use, that can be quite heavy. So these are the things that we've seen. So just a misuse, too busy, too chatty microservices.
And I think it seems like it would be something very common, right? Because everyone, as we've discussed before, a lot of people are still moving in this direction, right? So everybody is falling in love with the idea of we're going to break up our monolithic application. We're going to go to microservices. We're going to do a great CI/CD pipeline. We're going to do everything DevOps, and we're going to be the next. Well, they're not unicorns anymore, but stallions or horses or whatever, right? I almost feel that internally at an organization, there's a great risk to see how far they can break it down. Like, we could take this giant monolithic thing and break it down to 5,000 services. Look how cool this is. They're all individual, right? We're all individuals. If you ever watched Life of Brian, but that almost feels like it's an accomplishment, right? How far we could break it down. But the issue then comes into exactly what you're saying is, if there's especially in the case of a one-to-one relationship, you went too far. And now you're adding slowness and overhead and resource consumption to that, because now you have to make a network call. And that analysis, that's very important. I mean, again, you can maybe look at your code, you can look at some of these things and get an idea. But I think the next important step is then to properly, when you make your first attempt at your break apart, when you first break it apart and start testing it through, take a look at those dependencies at that point as well, and monitor the calls between them and everything else. Going.
Yeah. No, and maybe again, we have to give another. I mean, the way I would do this, if I have a tool like Dynatrace available, obviously the PurePath gives you a great overview to see which method and which component calls which other component. But in this case, I would actually think the sequence diagram that we have in Dynatrace is actually really great, because it shows you very nicely how components communicate with each other and can be a good indicator on which components are more isolated already and therefore are better candidates of ripping them out of the monolith and putting it into a service.
Right.
So that's one thing to keep in mind. So do your dependency analysis before you do anything, like just building microservice just because you can build microservices. It doesn't make sense.
Right.
And then you also mentioned the one-to-one relationship. I think Martin Edmeyer, he wrote a blog post about this,
right,
where he also talks about detecting these very tightly coupled services. And if they are really tightly coupled, then again, think about, does this really need to be an extra microservice? If it has to be, then at least be smart enough about the deployment of those. Because if you have very tightly coupled microservices, then also please deploy them close to each other to actually avoid the overhead of potential network latency. So
that would be a bad candidate for putting one in private cloud and the other in the public cloud?
Yeah, something like that. Yeah, that's for sure. And that's and these are all things that you have to consider, obviously, and that you can already, analyze and
right,
before you actually go into production. And this is something that I would hope software architects are doing, and I'm sure that most people do, but it seems it happens, right? And that's why we have these blog posts from customers to tell us about it. The world is not perfect, right? And so this is one of the problem patterns, just too fine grained, and then in a way to name it again, the N+1 query problem.
Yeah.
Because if you are making this so fine grained and you have existing code that makes in a loop calls to a certain class, and this class is now a microservice, then these calls in the loop become microservice calls, right? This was one of my first blog posts I did from monolith to microservices, the N+1 query problem between microservice calls, the Swedish company with the search service, and so be aware of that.
It's amazing how much the N+1 query pops up everywhere.
Yeah.
It's almost like a plague. It really is. It's like there's no getting rid of it. It's astounding. Yeah.
Well, the thing is also that, I understand it too, because Because I think development frameworks are, make it easy for developers to build stuff in a very fast way, and sometimes they hide away complexity. And these frameworks are also not always perfect, and also sometimes generic. And if you use it in a generic way and you don't think about how to adapt them and configure them for your use case, then you just end up with things like that, right? When we used to talk about Hibernate over the last couple of years, and it's the same. Hibernate is a great framework, but if you don't configure it and adapt it to your use cases, then it can do some horrible things.
Yeah, and the one warning always with the N+1 query is, you might even look at a transaction and say, hey, this transaction only takes, 200 milliseconds to execute from end to end. I don't care that there's an N+1 query. And in fact, my N+1 either query or service is only contributing 20 milliseconds to the whole thing, right? But don't let that fool you, because there's a lot more than just the amount of time, right? There's the amount of threads, there's the amount of connections, there are the bytes. There's also the unexpected changes in traffic or changes in usage that can suddenly take and blow that up on you. So, I just, there was a really great example. I wish I remembered it. As we were talking about it, I remember hearing about, with one of our customers where they had one of those exact situations where it was so minor, and then the next day it took and blew up on them for like a completely unpredictable reason. But just because it existed, it was a liability. So I would just say, don't ignore the N+1 query or the N+1 pattern problem.
Yeah. And I just, I always like analogies. The analogy with microservices that always comes to mind for me is if you go to a supermarket, and if you go to, you have your basket of items, and then you go to the checkout, and then let's say you have 5 items, and if the cashier, if he's a service and the only thing he does well is basically putting the final price into the system and then giving it a total, but every time he needs to get the price for a single item, he needs to call another service to tell him the price. So in this case, I give him my first item, then he needs to walk over to the person that tells him the price, comes back, puts the price in, and then I give him the second item. That's basically kind of the analogy for me. So the question is, how fine granular do we need to have these services? Do we really always need to go to that other service to get a certain part of information? Right. And also, how far away should this person be or this service be to optimize the paths? Right. That's the end. What we have to care about. I
used to work at a supermarket and used to work checkout.
Yeah, really?
Oh yeah. And my favorite was always having to do a price check. It was always the worst, because then suddenly everybody in line would groan. But that's what your customers are going to do if you have to do this piece, right? They're going to groan.
But the cool thing with this is, right, if you see the cashier as a microservice, you can scale it out by just adding more cashiers to it. Yeah. That's the beauty of it. Yeah.
All right. We're at about 30 minutes. Do we want to go ahead and tackle the last one we were going to?
Sure, why not?
Sure. Okay, we had one more problem pattern we wanted to discuss today. We are not going to open up an entire Pandora's box, because we're going to discuss a little bit about memory, right? And obviously, as soon as we say memory, there are about a million things we can talk about, and very, very in depth. Memory is very, very complex, and it's very scary. Anytime you see a memory problem, that's when I think everybody kind of starts shaking a little bit, because they can just be so painful. But today we're going to take a look at one that's hopefully not as painful, not too painful. We're going to take a look at garbage collection, right? And we all know garbage collection is necessary. It has a great function. It's part of life, right? It's like breathing. It's an application breathing, and has to have, or I should say, really, it's kind of like going to the bathroom for the application. Well, that's why they call it a dump, right? And the heap. We have all the fun terminology, right? But the point is, garbage collection happens, right? And no matter what, there's going to be some kind of impact to your application. And again, that's the cost of running an application that does garbage collection. The problem is when that has an impact on your application that is beyond, or that's a negative impact that you can feel, and, or your customers can feel, right? So let's get into a little bit of GC.
Yeah.
Andy?
Well, GC, or I think what we call it,
suspension,
because it's suspension. Yeah. It's really, It's really when the garbage collector kicks in and actually suspends the JVM or the runtime, and actually suspends your current critical transactions that are executing. And that's what I think what you try to get to is garbage collection itself, has to do, it has to run, and it will obviously, when it does major GCs, block your JVM for a while. The question is, how long are these blocks and who are they impacting? And maybe they are impacting transactions where you have SLAs with, right? You have a certain service level agreement, or if it goes beyond a certain threshold, then you are going to make your users unhappy or whoever else unhappy. So, and that's why what we always look at is suspension time impact on transaction response time. So in our terminology, from a Dynatrace perspective, we always talk about runtime suspension and the portion of the portion of time it contributes to the overall response time of a transaction.
Now, interestingly enough, let me cut you off there, because just before we were talking about response time, duration, and execution time total, right? And I believe when we look at this, we're talking about the suspension impact on the duration.
Exactly, but I mean the suspension duration on everything that happens within the execution of a transaction. That's true, yeah. And
I mean, as far as which one of those ones we're looking at when we take a look at that from that point of view.
Yeah, well, I think it will impact response time and duration, because
of course, yeah.
And so I think the thing that I'm always looking at is, when we are analyzing performance-related problems due to garbage collection, we always look at the percentage of time that the runtime suspends the threads, and which threads are currently executing business-critical features, and how long they are actually suspended, and what the percentage is of that suspension time to the overall execution time of the transaction. And so I typically, put graphs up when I analyze load tests or systems in production, and I look at overall response time, and then I look at response time without garbage collection impact,
right?
Because this is actually then the ratio. And what I like, again, we're doing a lot of pitches today with Dynatrace, but in Dynatrace you can also do a ratio with a ratio measure.
Yeah, I was just going to say, Reinhard and I do that a lot too in our things too. Exactly.
Yeah. So the ratio measure is great because it calculates the ratio between the response time and the response time without garbage collection. And so you can actually see what the real percentage impact really is.
Right.
And if you chart this over time, then you can actually see at which under which load you hit a certain threshold where garbage collection really becomes a problem for you. Also at which time of the day, when you have certain load patterns, you may hit a certain threshold.
Change? Or with a code change?
It's a code change, yeah. Exactly. So if you are deploying a new version, and then all of a sudden you see memory behavior changes, and now you have more impact. And then obviously the remediating actions can be different ones, right? It could be your memory behavior changes for a good reason because you changed some code and that just requires more memory, but maybe you forgot about to adapt your GC settings, your memory settings, or maybe you really have memory issues where you're simply consuming too much memory, causing too many garbage collection runs in the end, and then you obviously need to do your memory diagnostics and figure out how to be more efficient with memory usage.
Maybe you're keeping those threads alive too long.
You're keeping those threads alive too long, yeah.
So the interesting thing about this one, this is a pretty difficult one to look at, right? Because this one requires using JVM-TI, correct?
Well, in order to see,
I mean, we could see a GC run, we could see some of the pieces, but some of the nitty-gritty details.
Yeah, so I think what you're getting to is there's different approaches on how to measure this, right? Let's say there's different approaches on how to instrument JVMs and CLRs, and for Java now. There's two options, right? You have a Java agent, which is convenient and easy. The only problem with the Java-based agent is that it runs within the JVM. So the code that the tool uses to actually analyze performance is also suspended if the garbage collector kicks in, and therefore this tool doesn't even know that garbage collection just happened. And there's the other approach that has been around for a little longer, which is using the native interfaces of the JVM TI, the tooling interface, where you kind of sit outside of the runtime and therefore actually understand when the GC is triggered, how long it takes, and also who is impacted by it. And this is then the approach where you can really figure out what is the real impact of a GC suspension on which threads. And if you know the threads and what they're executing, then you can also assign it to your business features, and you can say, this feature was impacted by 50 milliseconds, which is 60% of our overall response time, and it's a critical feature, and that's not acceptable.
Right, and the interesting thing too is you could, with much less success, right? If you're looking at some of the JMX metrics type and all, and you could see, all right, there was a garbage collection ran. It ran for 200 milliseconds, and it ran at 10:05 today. And at 10:05 today, we also saw a spike in response time. So we'll assume that was because of the GC, right? But that again is kind of, you're correlating. You're tying two events together that look like they're related, but they might not be. So getting to that JVM TI tooling aspect is where you get that definitive answer. So it's
actually,
just.
I never thought about that. That's a good one. That's a very good one. Yeah. If you just look at that's actually
Because there could be plenty of other things going on, right? But you also wouldn't know that impact to those to the business functions as well. So that JVM TI piece is really important. And I know it sounds like I'm plugging, but it's. When I learned about this piece, I think about 4.5 years ago or something, or maybe 5 now. It's been a while, I just understood the criticality of it. So I'd love to.
And by the way, I think we had, if people want to learn a little more, we have.
You did a great performance clinic on that, didn't you?
I did a performance clinic too, but what I also wanted to say, we have the book with the Java Enterprise book. We wrote
that's right.
A while ago. So if you Google, it's on the website. It's a free book.
We'll put a link up. But it's
where I think it was Michael Kopp back then. He wrote several. I think he wrote all the chapters on memory management, explained how garbage collection works, and also the impact of garbage collection. That was a phenomenal piece that he wrote.
It's under, I believe, Java Enterprise Performance ebook.
I just Googled for Java Enterprise Performance Dynatrace, and it's under dynatrace.com/resources/ebooks/Java book.
Yeah. So what did you? We'll put the link up, but for people who don't go to the link, what did you did? Dynatrace Java. What did you search for?
Dynatrace Java book memory. That's what
I think it comes up like ebook Dynatrace. Yeah. So
exactly.
So you'll see that there. It's definitely good. That's where actually I started really learning about memory was from the early version of that book that was being put up there. So it's a great thing. And the nice thing is, even though it was written, several years ago, memory doesn't change too much. This is not like,
it holds true. Yeah.
Right. So definitely still worth going into. Anything else on the memory there?
Well, I think memory, as I said, as you said in the beginning, is a huge topic, right? I think we should have probably other sessions where we can talk about object churning, where we can talk about memory leaks, and different ways to analyze memory problems. But for this particular one here, I think it's just important to understand that try to figure out what the real impact of garbage collection is on your business functions. And figure out if this is load related, if it comes in through a different deployment that you had, or in case certain memory aggressive features are executed and then impacting all the other features that are currently executing in parallel. But always try to figure out what is the impact of garbage collection suspension.
Absolutely. And if you for anybody listening, if there are certain aspects of memory you would like to hear us discuss, by all means, please tweet it at us. You can tweet at pure_DT. or at either one of our regular Twitter handles, so at Grabner Andy or at Emperor Wilson. Or you can email us at pureperformance@dynatrace.com. Any other kind of problem pattern type of things that you may be interested in that we haven't covered yet, please as well let us know, and we'll dive into them. We're always looking for finding out what is interesting to you. I'm still sounding all public radio. I think this will be. I'll call myself Silky Brown. Andy, as always, the problem patterns are great, and I'm so glad that you see so many of them. We all see them quite often, and I'm sure a lot of our listeners run into them all the time. And hopefully we're doing a little to help you identify or be aware of some of the more common ones, because as you told myself and many audiences over and over again, right? These, we call them common because they are common. They happen everywhere, and they happen in the best of shops, and they happen in the worst of shops. There's just no getting away from them. It's kind of like mosquitoes. They're always there somewhere. So again, great stuff there. Anything that you'd like to, any final words from you, Andy?
No, not really. Just keep sending us data, and keep approaching us with things that we can then take, analyze, and then bring it to a broader audience, either through the podcast or through blog posts. I think with that we can all make our little contribution in improving the engineering world. Excellent, well said. Give back. There you go. That's what it is. And we're having our fun drive. Yeah. All right. Well, with that, I'd like to thank you, Andy, Thank you for doing this for me. And again, it's about a year, so let's wax nostalgically for half a second. And thank you for all of our listeners who have been enabling us to do this. We do this as part of our day job, right? So because we have listeners like you wonderful people, we get to continue doing this, and we really enjoy it. So just a big shout out to everyone who's and everyone who listens, and everyone who's encouraged us to do this, especially the one, the only Mark Tomlinson, who was he's the one who kept pushing the two of us to do this. So shout out to Mark, and I guess we'll give a little shout out to Steve. Yeah, Steve is listening to us on the way into work, he told us. Yeah. Right, and also Brett. Yes, hi Brett, guest of the show. Anyhow, and all right, well, we'll talk to everybody. We'll see you all soon, and until next time, ciao ciao. Ciao.